which are in the notes number 2, look at first plotting a circle with a center at 0, 0, 0 in the XY plane. So let's try to do that. Go into Revit, and in the first of all, I'm going to set the units, project units. Where are the project units here? No. Project information, blah, parameters, shared parameters, project parameters, blah, blah, blah. Project units, okay. So these are the exercises in note number 2, and we are going to set the units in the Revit file to meters, not decimeters, meters. Okay. And now I'm going also in the Manage menu of the new file, go to Dynamo. And with this, I'll go to the new file and I'll maximize. So the first task in this was to plot a circle with a center at 0, 0 in the XY plane. Well, this cannot be easier if I just type circle by center point radius. Hey, it's already there. Circle with a center at 0, 0, 0. So in this circle node, the center is by default at 0, 0, 0, and the radius by default is 1. Of course, if I want a different value, I can put in the coordinates as a different type of coordinates. So you can see that the input here is point. So I could put here a point and perhaps change this so I can use for the x coordinates maybe 5. For the y coordinate maybe 10, and for the z coordinate maybe I don't know, 15. So I would then connect the coordinates for the point, and then the point will be the new center point. And now this circle has moved. And also I can put a different radius for a circle, for example, 10, maybe 12, okay, it will be different. And that will be this different circle. So this is quite straightforward. The input, it says here, has to be a point. Here the input is a double, which means a number, double precision number. And then for the points, the inputs are 3 variables. So that has given us the circle. Now the next bit was, we've done a bit more than we were asked for. So the next thing is to modify this circle into an ellipse by multiplying the radius in y direction by a factor. So clearly, we have no option how we can do that here. We have this circle, and if you turn it around, you can actually see it is a circle. And to modify it into an ellipse, why is it not turning? Okay, to modify it into an ellipse would be impossible using the circle command. We could use the ellipse command, but that's not what we are asked to do really. We are asked to modify the circle. So we need to plot our circle in slightly different way. So I will remove all these nodes that are here, and that removes the circle as well, and try a different method of drawing circle um, using the sine and cosine. So we know that in trigonometry we have um, the x coordinate is equal to radius of circle times cosine angle, and sine times radius is the y coordinate. So we can use these coordinates of a circle to place it by adding a radius, let's say 8, and angle. Angle going from 0 to 360 with, let's say, 10 degrees step. So I can rename these code blocks to radius, angle, and accept. So now to draw the circle, I will need to find the cost. So what I will use to plot the circle is just the NURBS curve, like we use for the sine function, but just like for any function. So NURBS curve by control points, and the input to this is point, so we need a point by coordinates. And the point by coordinates requires x, y, and z. Now z will leave at 0 because we want the circle to be at the basis, at the base. But x coordinates will be radius times cost of this angle. So if I enter here cost function, I can feed the angle in the cost, and it will give me so this code block is a series that created 37 values of the angle, starting from 0 to 360 in a step of 10. And here we have also 37 values of cosine, double precision, so that is quite a few decimal places. And now I have cos of an angle, but the x-coordinate is r times cos. So I need here a times node, and this node requires two elements to input. The first one is the radius, the second one is cos, and that is my x-coordinates. So x-coordinates are r cos angle, r times cos angle. And now for the y-coordinate, we can use sine of the angle, and again I need to multiply that, so I need another times, another multiplying node which now has radius times sine times sine. So this feeds into y coordinate. And really, although a little bit messy, this gives the same sort of graph, although now it is just points. It is just the points, but once I connect this here, it will give me the line. And if I actually untick the preview, it will show me just literally the circle. Just the circle. And so this has given me the same answer as just using the circle command. But this has now the ability to change what is in the y direction. So instead of multiplying r times sine theta, in the y direction we can multiply that by another factor. So r times something is the new radius. So if I type here, if I double click to put a node block and just put here, so r sine angle times new times multiplier, let's say multiplier. R sine angle is this value. This is our R sine. Sine times radius is this. And the multiplier, well, we can put the multiplier like this, or I can actually put the multiplier as a slider. Maybe number slider. And I can have it maybe from 1 to, okay, from 0 to 3 maybe in steps of 0.1. And so now it's at 1. So now this one I will connect to the multiplier, and then this now becomes new y coordinate. So that is going into the y. And now nothing has changed. So we multiplied the y coordinate by multiplier, but that's because multiplier is set to 1. If I move this, we are getting now ellipse. So in the x direction, the radius is the same, but in y direction, we are multiplying by these values, the radius. So this was the second task, which was to modify the circle into an ellipse. And now we need to modify the circle into a helix, add the z coordinate for each point. At the moment, in our program, in our code, the z is 0. The value for z is 0. But we want now to give z a value. So for each angle, let's say for each angle, we can have here z coordinate is equal to angle times again it is some multiplier, let's say height, h. Angle times h, where angle is this, and for h I can put for h maybe again a number slider where my h goes from 0 to, let's say, zero point 0.3 with a step of 0.05. So what this means, is that for each angle, for each point, basically, the height is equal to the product of angle times this parameter h. And this we need to feed into our set. Make it a little bit smaller. So this is our this is our helix. However, it doesn't look like a helix because it should go on and on. But the reason it stops is because we set our angle to 360. So if I change this to maybe 1080, it looks really like a helix. So we have modified this into a helix. We could now kind of tidy up this as well a little bit. So this and this. So these two are our geometry. Create group, call it geometry. Then this is really the ellipse bit, and this number slider is our ellipse multiplier, and this is our ellipse. So these two nodes could be grouped under ellipse. And I can change a bit the color, and then all these are to do with the circle. These two are inputs. These are to do with the circle. Circle. Oops, no. Okay. Circle. And this one and this one are to do with the helix. Create group helix, and I can call this like that, orange. And these two are inputs. Now this is now the third exercise solved, and then the last exercise is to create now a solid helix with the circle of the radius 5 is swept to create a solid helix. So I will just do something to pause the note. Okay, so in the previous um, talk, uh, we created this helix and explained how it's done using the r cos angle, r sine angle for x and y coordinates, plotting the circle, and then changing that circle into helix by adding the z coordinate for each point on the circle. And these points are now hidden, but they can be displayed if we unhide them. So these are basically points through which we created this curve using the NURBS node. Now, our next task is to create a solid by sweeping a circle of radius 5 along this helix. And we need to use these nodes: curve, plane at parameter, circle by plane radius, and curve sweep as solid. So let's start with a curve. Let's start by opening all these nodes. First one will be curve plane at parameter. So if I type curve plane at parameter, um, what this does is it returns a plane whose normal aligns with the tangent of the curve. That's what we need because we want our circle to be normal to the line, to the curve, in order to sweep it as a circle, not deformed. If the circle lied in the xy plane, it would be deformed. So this curve at plane at parameter is the first node that we need. Then we need another one, which was circle by plane radius. So this creates circle which lies in the input plane. So this will help us to create a circle which lies in the plane normal to the helix. And lastly, we need the node um, sweep node, sweep, and this is really curve by sweep. Oops, not surface. Delete. Solid. So we need sweep, sweep as solid. So curve sweep as solid will create a solid from a circle swept along the curve. So that is what we need to use, and we can see here that for the curve plane at parameter we need the input, which is curve, and our curve is the helix, which is this one, and parameter, it already says default value is 0, so that is at the point 0, for the point 0 on that curve. The point 0 on that curve is basically the start, which is the point that we need. And this outputs a plane, and this is clear if we go here. So this has already created here a plane, and it's visible here. So um, to sweep, we need to sweep the circle along that plane. You can see here the circle because we have this circle by plane radius. Because of the default value, it has already created a circle. But now our circle, so we don't need a parameter, default value is fine. So now our circle plane for this is this plane. So the plane of normal to the helix at the point 0 is the plane in which our circle of radius 5 will lie. So I need to put in a code block and put here 5, which is the radius of the small circle. And now if we look again, we can see that our circle is here, is actually created, and it is inclined. It's not in xy plane, it's actually in the plane normal to the helix. Now this radius 8, I will increase a little bit, maybe to 20 or 30, radius 30, um, 20. And now, yes, my helix is now increased. The radius of the helix is now increased. And the only thing that remains is to take this circle as a curve which is being swept and swap it along the path which is our helix. Looks a little bit thick, so let's maybe increase this to 30, and that's a little bit better. So here is our helix. We can look at it from a slightly better view. Okay. I think I need to increase also this to maybe here. Right. Right. So we can see now this is our helix, and we can modify the radius and all that uh, in our program. So this is all for the exercises in Dynamo, but I will post some more exercises for practice.